Hello, welcome to PaperCam. I've got hands. So we are looking at chapter 17 now. This is a brand new chapter with a brand new mechanism. Note the title, nucleophilic addition to polar pi bonds. So we're talking about polar pi bonds. What does that mean? Different set of functional groups. So looking at reactions of something like a ketone and likewise its friend, the aldehyde. So what do these two things have in common? Well, they have really similar functional groups in that you have a part here which is more positive and a part here which is more negative, right? So you have a polar pi bond, a positive and negative. This is different than the way the alkenes reacted. Two other functional groups that fit the bill there are these two. So you have an imine and a nitrile. So these look different, but they're not that different. So you have a carbon double bonded nitrogen. Nitrogen is still the more negative end. Carbon is still going to be the more positive end. So if you're doing a nucleophilic addition, right, nucleophiles are more negative, it should be adding to the positive end of this pi bond. Right? So the generic mechanism then looks a little something like this. So let's take our ketone. If we're reacting that with a nucleophile, of course, we already identified this. So this is a polar bond, more positive on the carbon, more negative on the oxygen. So a nucleophile is going to add here. Then what? So the weakest bond here is the pi bond of the double. So that will break, push the electrons up towards the already more electronegative oxygen atom. And then you get that with a nucleophile added, right? So this still has charge. This is an intermediate. Okay, didn't need the little charge there. What do we do from here? So what we do from here is I've got to get rid of this negative charge. There's nothing left in my reactants, so I need some sort of acid to do a proton transfer and make an alcohol. Right? So this is the generic mechanism that's going to work for pretty much all these steps. So nucleophile adds first, negative to positive there, push the electrons up on the oxygen, get an O minus. Right, so go from a ketone to an intermediate, add something that can do proton transfer, solvent, water, strong acid, and then you get an alcohol as the product. All right, so here in this case we went from ketone to alcohol. Right? We could do the same sort of reaction with an imine to show, okay, so the imines aren't so different. Right? So if my nucleophile attacks in this carbon position again, the electrons are going to push up to the nitrogen now. Notice it's pretty much, it is identical functionally here, other than there's an N here. So my nucleophile has connected. Now a single bond to a nitrogen, which is going to have a negative charge. And then this is going to have to do a reaction with an acid. My nucleophile's added. Instead of OH, I've got NH2, right? So I went from an imine to an amine, right? Same mechanism though, sorry. Same mechanism, it's still the exact same either way. So this is a nucleophilic addition to a polar pi bond.